All right, variance. Actually, very, very similar to standard deviation. It's actually one shorter than standard deviation. So we'll do a couple of these problems, and then we'll call it quits because we just walked about standard deviation, and once again, almost to standard easier. So I'm writing my numbers down now. 8, 4, 14, 16, and 8 are our numbers. The question is what you have found the following ages in years of all 5 gorillas at zoo. What is the average age of gorillas at your zoo? So let's first find the average age, which we have to find no matter what for standard deviation. We're actually going to find standard deviation. We're just going to stop one step short. Okay, so first off, let's find the average. So we have 8 plus 4 plus 14 plus 16 plus 8. We get 50 divided by 5 gives us 10. So the average of those numbers is 10. And we can type that in right meow. There we go. Now variance. Like I said, it's like we're doing standard deviation. So we're going to take these numbers and subtract it from this number. So 10 minus 8, 10 minus 4, 10 minus 14, 10 minus 16, and 10 minus 8. 10 minus 8 is 2, 6, negative 4, negative 16, and 2. We got to square these. When we square them, we get 4, 36, that's 16, that's also 36, and that's also 4. Okay? Now, the variance, once we just find the average of these, that's our variance. All right? So we're going to add them all up. 4 plus 36 plus 16 plus 36 plus 4. Our total is 96. We're dividing by 5. Our variance is 19.2. Okay, now remember, standard deviation, we would take the square root of this number to get standard deviation. The variance is this number right here. Like I said, it's one step short of standard deviation. So we get 19.2. Before I check is, so 19.2 is our answer. The notation for variance, it's a little, I forget what it's called. I'll look, mu, actually, it's mu. So mu squared is 19.2, and then regular mu stands for standard deviation. So if we wanted to find standard deviation, we would square root this number, and we would get 4.38, okay? So if you see these things on a test or anywhere, this stands for variance and standard deviation. All right, now let's go back and check point 2, yep. Waiting, and we're right, excellent. Okay, I'll do at least one more, and then we'll call it quits, because at this point, it's kind of beating a dead horse. You know how to do it now, hopefully. But these do take some practice, just because it's just, you know, a little bit of work. All right, so we have zebras now at a zoo. 7, 1, 9, and 14. So the first thing we have to do is find the average. 7 plus 1 plus 9 plus 14. We get 31. 31 divided by 4 gives us our average. So that's x with a line over top is 7.75. Okay, that's the first part of our answer. We'll put that in later. Now we're going to take these numbers and subtract it from this number. One thing, it doesn't matter which numbers come first, if it's this number or these numbers, because once you square them, the negative will go away. All right, I had to pause the video. I had to talk to someone for a while, so I'm a little distracted. So we were doing these numbers minus 7.75. Okay, so equals. If you can't do these in your head, feel free to use a calculator. Oops, I just realized this is not on the screen. All right, back to what I was saying. So we're doing 7 minus 7.75 all the way down. We're doing equals. And if you can't do this in your head with the decimals, use a calculator. That's fine. I'm not going to use a calculator because I can do it in my head. So that's negative 0.75. 1 minus 7.75 is negative 6.75. This is going to be 1.25, and this will be 6.25. Now we're going to square all these. I'm going to erase this 7.75 because it is in my way. So average 7.75. It's up there. Okay, so we don't forget it. All right, so we're squaring all these things, and now I guess we could use our calculator. Negative 0.75 squared is 0.5625. Negative 6.75 squared is, what is that? 45.5625. We have 1.25 squared is 1.5625. And finally, we have 6.25 squared, which is 39.0625. 0625. All right, we're going to add all these up and find the average, and that is our variance. So 39.0625 plus 1.5625 plus 45.5625 plus 0.5625. So all four added up together is 86.75. We're dividing by four numbers, and we get 21.6875. I believe we are rounding to our hundredths. No, tenths. Okay. 21.6 up to a 7, because this is an 8, which is bigger than 5. So 21.7 is our variance. And the average age was 7.75. I just realized this is a different question than we had before. That's a bummer. Huh. Okay, well, the question changed from when I was working. Maybe it's right here. Oh, here it is. Okay. Here's our answer. So this is 7.75. And then this variance down here is, like I just said, 21.6875. Oh, and we're rounding to the tenths. Okay, I forgot about that. 21.7. Sorry, I'm really distracted right now. Average up. So because we're going to go to the tenths, we have to average, or not average, round up that 7 to an 8. And that should be our answers. Interesting. What did we do wrong? Don't know. I figured I did it wrong. I didn't read the question closely enough, and there's something that's kind of important here. So up here we have 4 zeros. Because they're randomly selected from a bunch of more, we don't. When you're not using the full sample size, you're only using a portion of it. Instead of dividing at the very end by 4, when we get to our variance. So right here, when we added all these numbers up right here, we got 86.75. Okay, and I divided by 4. This is only the case when you actually know that you have all the numbers in your sample. We only have 4 zebras out of 45. So when you do that, because it's going to throw off the estimation, we actually divide by 4 minus 1, or whatever numbers we have minus 1. So instead of dividing by 4, we should divide by 3, which gives us 28.9 instead. Okay, so that was my mistake right here. I just didn't read the question closely enough, which, you know, happens to all of us. And we'll check again. And there we go. So once again, we only have 4 of 45. So if we're taking a small portion out of the entire sample size, instead of dividing at the very end by our total number, which is 4, it's going to be that number minus 1, which would be 3. Now, if we had 45 numbers up here, and we did a whole variance list of 45 numbers, you would divide by 45, not 45 minus 1. So that was the difference there. Let's do one more. Let's end on a high note. Okay. Okay, so we found the following ages of all 4 bears. So this is, remember, very important, all 4 bears. So we'll divide by 4 at the very end, not by 4 minus 1. Okay, so the average first is 5 plus 4 plus 6 plus 39, very old bear. Divide by 4, we get 13.5. Okay, so here is my work. Our average is 13.5. Let's write down. We have 5, 4, 6. and 39. Okay, so I'm going to do 13.5 first. Minus 5, minus 4, minus 6, and minus 39. So if you can't do this in your head, minus 5 is 8.5. Minus 4 is 9.5. You can probably figure this one out, 7.5. And then 13.5 minus 39 is negative 25.5. We're squaring all these. So 25.5 squared is 650.25. 7.5 squared is 56.25. 90.25 and 8.5 squared is 72.25. Add these all up, and we're going to find the average of these numbers, and then we are done. So 869 divided by 4, 217.25. And I assume we're rounding to the nearest tenth, which means if that's the case, it would be 217.3, and our average is 13.5. Let's see how they want to nearest tenth. So 13.5 is right, and variance is 217.3. And there we go. And one thing, just to clarify one more time, because we have all 4 of the bears in the zoo in our sample size, we divide by, if it said 4 bears of 20, you would do 4 minus 1, which would be 3, and we would have divided at the very end our big number divide by 3 instead of by 4. Okay, that was what I did wrong last time. I just didn't read the question clearly enough. And we're done for now.